Good afternoon, students. Is my screen is visible? Am I audible?
Yes, sir.
So, welcome to the module 33, right? 33rd class of IC engine subject, right? So, in this class, we are going to see about the types of the cooling system, right? What are the types of cooling systems there, and what is cooling system, right? So, before entering this class, just we can recap what are the terms we discussed in last class. So last class we discussed about the various types of the lubricating system, right? So for the lubricating system, we have three lubricating systems. So one is the mist lubrication system, right? So in the mist lubrication system, there is no special one, right? Why? Because uh, there is no oil terms. There is no oil pump, oil sump, right? So oil pipeline. So that is nothing there in the mist lubrication system, right? So why? Because we have to supply, we have to give the oil, lubricating oil, right? So it's nearly 2 to 3%, nearly 2 to 3% of the fuel, right? The fuel tank itself, we can supply the oil, right? So it will be passing through the carburetor, right? So once the fuel gets vaporized on the time, we can get the oil mist, right? The oil mist also mixed with the air fuel mixture, and it will passes through the combustion chamber, right? So there we can get lubrication, right, through the oil mist, right? So in that oil mist lubricant system, we have plenty of disadvantages, right? So due to that disadvantages, we can switch over to the other lubrication system. So one is the wet sump lubrication system, right? So here you can see in this diagram, so there is an oil sump, right? Oil pan is there, right? So at the bottom of the engine, right? So in the crankcase, in the bottom of the crankcase, we have some oil pan, right? So in that oil pan, we have some oil. Then that oil will be pumped to the elements, right? Pumped to the systems, right? So what will happen? So here all the mechanical elements will get lubricated, right? So these parts will be get some lubrication will be there, right? So this type of lubrication is called the wet type lubrication system. So in particularly in the wet type lubrication system, sub classifications are there. So for the wet lubrication system, right? Uh, we have three sub classifications. So one is the slash lubrication system, and the second one is the semi pressure, and third one is the full pressure lubrication systems. Right. So that we discussed in last class, right? So for the splash lubrication system, so there is a scoop type uh, projection is there, right? So for the scoop type projection, what will happen? It will be dipped into the oil sump, right? So the oil will be passing through the oil pump, then it will be stored, or it will be passing through the oil through, right? So for the every cylinder will have a separate oil throughs, right? So the connecting rod will have uh, the scoop shape projection. So it will have some scoop shaped projection. So once the the connecting rod will be rotates, right? So on the time, what will happen? The right. So on the time, what will happen? The scoop will be splashes the oil, lubricating oil into the cylinder or a chamber, right? So then we can get a lubricated, right? The system will be gets lubricated, right? This one type of system, lubrication, splash lubrication system, and we have semi pressure lubrication system, right? So in some more conditions, we have some small holes and cavities, right, inside the shafts, right? So through the shaft, we have to supply the fuel. Sorry, we have to supply the lubricating oil for the lubrication purpose, right? So that oil will be passing through the small hole, that is the passage, which is drilled by the other machining process, right? So the lubricating oil will get into the shaft, and it will be passing through the entire system. So the system will get some lubrication. So here we have to supply the fuel, right? We have to supply the lubricating oil inside the cavities or inside the passage. We have to give some pressure, right? So that pressure will be a limited one. So it is the semi pressure, right? So in that semi pressure, So the special is right in the semi pressure. So we are using the pressure as well as the splash, right? So both are there, right? So for the splash and the pressure, right? So here you can supply the pressurized fuel, right, into the oil tubes as well as in the shafts also, So here we are using the two, right? Pressurized fuel will be passing, pressurized lubrication will be passing through the cavities, and the splash lubrication system also there. So this type of lubrication system is called the semi pressure lubrication system. And the third one is the pressure, right? Full pressure lubrication system, right? So there is no splash lubrication terms, right? So here there is no scoops, right? So only the pressurized oil will be sent through the shafts, right? Sent through the shafts or in a small holes or small passages, right? So the oil will passing through these passages. So what will happen? So here some lubrication will be occurs, right? So the lubrication, whatever will be the lubrication, right? So the outlet of the lubrication will be in the terms of the gravitational force, right? So once we have to lubricate all the elements, right? So the remaining liquids or remaining after the lubrication, the oil will be again it will be comes into the oil chamber or oil pan, right? So oil pan or oil sump, right? So due to the gravitational force, it will be comes back to the oil pan, right? So these three are wet sump lubrication system, right? So why? Because for the wet sump lubrication system and another is dry sump lubrication system, right? So the difference between these two is here the oil will be always in the oil sump, right? So always the system will be in wet condition. So for that only it will be called as the wet sump lubrication system, right? So for the dry, next one, the next lubrication system is the dry lubrication system, right? So in this dry lubrication system, uh, here also the setup will be same, but here the lubrication will be supplied through the external force, right? The lubrication will be supplied to the system or engine, right, in a external source, right? So for the external source, we are supplying the just right, right. So now my PPT is visible. My PPT is visible.
Yes, sir.
Yes. So right in the dry sump lubrication system, like the oil from the sump or engine case, right, is pumped into the separate storage tank, right? So the oil will be supplied in a or in stored in a separate storage tank, the outside of the engine, right? So not within the pan, right? So for the wet sump, you can see the where the oil will be stored, right, in the oil pan, right? So which is mounted on the engine base, right? But in the dry lubrication system, right? So there is no tank, right, in the engine mounting, right? So we have a separate tank which is outside of the engine, we have a separate uh, tank, right? So the oil sump, that's the oil sump, right? So the oil from the sump is passes through the filter, and the function of the filter is to remove the abrasive particles from the oil, or otherwise the abrasive particles which causes the wear on the bearing surfaces. So we can remove the abrasive particles, and we can also remove the dust particles, right? So which is deposited on the bearing surfaces, right? So if the filter becomes clogged, right? So the filter bypasses the relief open valves and permitting the oil to bypass the filters also, right? So the oil from the storage or a supply tank is pumped into the engine bearing or cylinder, or right through the oil cooler, right, through the oil cooler, right? So here you can see, right, in this diagram, what are the terms you have. See in this diagram, what are the terms you have. So my screen is visible, my PPT is visible.
Yes, sir.
Just right. அப்ப பிபிடி தெரிஞ்சா உங்களுக்கு இல்ல இப்ப தெரியுதா?
சார் இப்போ தெரியல சார், இதுக்கு முன்னாடி ஓகே.
இது முன்னாடி தெரிஞ்சு இல்லையா? இப்ப தெரியுதா?
நோ சார்,
தெரியலையா?
தெரியல சார் இப்போ.
வெயிட் வெயிட். இப்ப தெரியுதாப்பா?
நோ சார்.
எஸ் சார், எஸ் சார்.
இப்ப தெரியுதா?
தெரியுது சார்.
எஸ் சார்.
Okay. 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 Fine. So you can see it is the engine system, right? So we have a separate fuel tank, right? And we have the separate oil pump and oil cooler, and it will be passing to the bearing means to the engine like that, right? So the bearing all to the engine components or the machine components, correct? Right. So in this diagram itself, you can see um, the oil will be storing from the storage tank, which is a separate part of the engine, right? So the oil from the storage tank, right, it's pumped into the engine system, or engine bearings or elements, right? So where the lubricant will be required, right, through the oil cooler, right? It will be pumped and it will be cooled and it will be sent to the engine system, right? So in the system, the oil pressure, it may varies from 3 to 8 bar pressure, right? So here the oil pressure varies from 3 to 8 bar pressure, and the pressure relief valve is used to prevent the excessive pressure, right? The excessive pressure buildup after the cold start of the engine. So we have to prevent, right? So we are using the pressure relief valve also, right? So the oil cooler reduces the temperature of an oil. So therefore, the dry sump lubrication system permits the use of the thinner oils, right? So it results, it decreases the frictional resistance of the engine. So the dry sump system is generally used for the high capacity engines, right? It is generally used for the high capacity engines, right? So this about the dry lubrication system, right? So so for the lubrication system, we have three lubrications, right? So these three are very important one, right? So it's a repeatedly asking questions, right? So for the university terms, university examination, they are asking the lubrication systems, right? Either they have to, we have to compare and write. So the how the wet lubricant system works and how the dry lubricant system works, right? So is it clear? So up to this, we covered lubrication system, right? So we have three types of lubrication system. One is the mist lubrication and wet sump lubrication and dry sump lubrication, right? So is it clear? Is it clear?
Yes sir.
Okay. Then we switch over to the next second part, right? So cooling system, right? So what is the cooling system, right? So in the engine, why we require the cooling? Why we require the cooling? And so you can see here, right? So here you can see. So what are maybe the simple engine, right? So we have the lubrication system. It's the main part, right? So here the yellow terms will be the lubrication one, right? And so here you can see, here you can see, and here you can see, and here you can see. So what is that? So while in the combustion stage, so it will develop the heat, right? It will develop the heat. So we have to reduce the temperature of the engine, right? So we have to keep the engine in a cooler manner. So the cooling system is required, right? Cooling system is required, right? So here you can see, right? It's a very simple one, right? So for our radiator one, right? So here the water flow will be there. So the water, the cooling water will be sent into the system, that is a engine. Then it will absorb the heat which is produced from the combustion stage, right? So then the water will be gets heated and it will be passes through again the radiator, then here the fan will be there, right? So the fan will rotate, then what will happen? The heat will be transferred. So the hot temperature water, the hot temperature water will get it will get cooled, right? So due to the fan rotation, right? So it's a simple heat transfer, right? So we have to transfer the heat of the engine to the atmosphere, right? We have to convert, right? We have to transfer the heat, so which is developed on the combustion stage, right? So in the engine, we have in the engine we may get some heat, right? We may get some heat, right? So we have to reduce the heat. That's our concept. We have to reduce the heat, or we have to transfer the heat which is developed by the engine to the atmosphere, right? So for the cooling system, right, the cooling system is broadly classified into the two categories. So one is the direct cooling or air cooling, right? And second one is the water cooling or the indirect cooling, or we are using some mediums, right? So for the direct cooling, right, so the heat, it is generated from the engine cylinders, right? So the heat from the cylinder valves is directly transferred to the surrounding air, right? So surrounding air. So that type of the cooling system is called direct cooling system or air cooling system. And in some more conditions, so we are using some external, right? We are using some external mediums, right? So here the water cooling or the indirect cooling, right? So here the heat which is developed from the engine, right? So which is transferred to the surrounding air. So through some medium. So either it is in water or whether it is in some phase change materials or chemicals, right? So that is the that term. We have to classify the cooling system of the IC engines broadly into two categories. So one is the direct cooling or air cooling, and second one is the water cooling or the indirect cooling, right? So these two, right? So direct cooling and indirect cooling. Then, so then we can see the first term, right? So what is the direct cooling or what is the indirect cooling? Sorry, direct cooling or the air cooling, right? So in order to increase the surface area, right? So in order to increase the surface area of the fin are provided on the metal surfaces, right? It is exposed to the cooling air, right? So for the we have seen in our bike, right? So in our bike, what type of cooling we are using? We are using the air cooling, right? So in that engine we have seen the fins, right? So the cooling fans are either the cast integral with a cylinder and the cylinder head, and they may be fixed separately with a cylinder block also. That type of the cooling system also there. So that also a air cooling system, right? So the various type of cooling fans, right, that will be shown in this. Here we have seen this type of the various type of the cooling fins, right? So the for you may see here the rectangular, and we have some tapered. So here we have some root and the trapezoidal fan and the triangular fin. So we have the various types of cooling fins are available, right? So the length and the spacing and the thickness of the fins represented by here as the L, S, and the T. So the L will be the length, and the S will be the spacing, and the T will be the thickness, right? So the heat transfer capacity of the system is depends on the temperature difference between the cylinder, right? Between the cylinder and the cross section of the fin and its length also, right? And the cross sectional length, cross sectional area of the fin and the length of the fin, right? So the heat transfer capacity of the fin, it depends on the temperature difference between the engine cylinder, right? Engine cylinder valve and the cross-sectional area of the fin and its length, right? So the heat is gradually dissipated from the root of the fin up to the tip of the fin, right? So here you can see in the engine, right? So in the engine, so here, right? So these part you can see. So the heat will be dissipated from this direction. The heat will be dissipated from this direction. So it is the cylinder wall, right? So you can see in this diagram, you can see, right? So these are the fins, right? These are the fins. So the heat will be converted from the combustion chamber to the cylinder wall, and the heat will be here. That heat has to reduce, right? That heat has to transfer to the surrounding, right? So here it is the surrounding one, right? So here it is the surrounding one. So the heat dissipated from the point, right, where the point is called as the root, right? So the fins, right? So in order to increase the surface area of the fin, right, increase the surface area of the fin, so we can get the higher cooling amount, right, and its length also, right? So the heat is gradually dissipated from the root of the fin, right, so up to its tip, right, so to the surrounding, right? So due to the temperature gradient exists along its length from the root to the tip, right? So at the tip of the fin, the heat transfer capacity becomes minimum. At the tip, you can remember this one. It's a important objective type question, right? So at the tip, right, at the tip of the fin, the heat transfer capacity becomes the minimum due to the least temperature difference, right? So hence the less efficient at the tip of the fin. So therefore, the thickness at the fin, right, it can be reduced, right? It can be reduced due to the decreasing quantity of the heat flowing at this point, right? So for the at the tip, right, at the tip, you can see in your bike, you can see, right? So how the fins will be there, right? So for the fin, it will be cast to the engine. So there the surface area will be have more, right? So at the tip, you can see the area will be reduced one, right? So why? Because it will reduce the quantity of the heat flow at this point, right? So why means there the temperature difference, right? So the temperature difference is minimum while comparing to the root area and while comparing to the tip area of the fin to the surrounding, right? So from the surrounding to the root area, so there is a high temperature difference, but in the tip and the surrounding, so there is the heat temperature will be at least one, right? So the heat transfer capacity is minimum at the tip of the fin, right? So this concept will be you can study this concept in the upcoming semester. That is the heat and mass transfer subject. You can study in full manner, right? So now you can just know about what is the fin and how the heat will be dissipated. So where the higher temperature difference is there and where the lower temperature difference is there, right? So that you have to see, right? So in that you can see the rectangular fins are the less efficient, right? So here we have the three type of fins, right? So what are the shape I mentioned here? So rectangular fin. So first one is the rectangular fin, and the second one is the trapezoidal fin, and third one is the triangular fin, right? So here you can see while comparing, right? So these, right? So it is the first one. So rectangular type fin, and here it is the trapezoidal one, and here it is the triangular one, right? So here the efficiency will be less on the rectangular fin, right? So well compared to comparing to the other two, it's found that the rectangular fins are less efficient and heavier compared to the trapezoidal or triangular fins, right? So the heat transfer rate, it can be increased by increasing the surface area, right? So that is why by increasing the number of fins, we are increasing the number of fins, we can increase the heat transferring capacity also, right? So however, the increased number of the fins will reduce the spacing between them, right? So which results to decrease the heat transfer also, right? So here you can see the two conditions, right? So once the surface area increases, the heat transfer will be increases, right? So as we plan, so we have to increase the number of fins, right? But if the number of fins will be increases, right, it will reduces the space between the fins, right? So that will decrease the heat loss, right? So for the every engine we have to have n number of, that is number of fins, it will be a optimized one, right? So we are not having the much amount of the fins, right, as well as the distance, right? So we have to see the two terms, right? So the number of fins is a very important one while designing the cooling system of the engine, right? So most probably the spacing between the fins is around 2.5 mm to 5 mm, right? So usually it is kept as the length of the fin will be 25 to 50 mm of length, right? So the spacing area will be 2.5 to 5 mm, and the length of the fin will be at 25 to 50 mm, right? So this two terms you may remember. Then then we have some advantages and the disadvantages, right? So every system we have some advantages and we have some disadvantages also. Is it right or not? Right. So first we can see the advantages of the air cooling system, right? So it's light in weight and simple in design. While comparing to other cooling system, wait. Right. So while comparing to the other cooling system, right? So the air cooling system, right? So it's light in weight, right? So and simple in design, right? So due to that, so we are not using any other the external coolants or external mediums or external piping system. We are not using that much more devices, extra devices we are not using here, right? So for the air cooling system, so only the fin is enough. Only the fin is enough, and more than the fin, we have to use one extra fan. That's enough, right? So its weight will be a light one, right? Its weight will be a light one, and the design will be a simple one, right? Then here we are not using the any other external, so external that is external devices, that is radiators or coolant or pipe connections or water jet again. So we are not using any external term. So the maintenance cost also is very simple, right? So we are not maintaining, right? So uh, if while comparing to the car, and we have to compare the bike engine, right? So which is a maintenance one, whether car is a maintenance one or a bike is a maintenance one. So for the bike, I may you may know, right? So we are not using or you are not maintained properly, right? So there is no maintenance in the bike fins, right? But in the car, you have to see the radiator, right? So whether the radiator water level is good or not, so whether the coolant level is good or not, so you have to see the terms also, right? So in that air cooling system, there is no maintenance cost. Why? Because it is a maintenance free one, right? It is the maintenance free one, right? So we are not using any, we are not to spend any amount for the air cooling system, most probably, right? Then the no antifreeze solutions also there. If we are using any coolant, then we can see, right? If we are using any fashion material, then we can see the antifreeze conditions. But here we are not using any terms, right? So there is no antifreeze solution is required, right? So it will be operates at low temperatures, right? Then there is no problem on any coolant. Why? Because we are not using any coolant. We are so there is no chance for the corrosion, and there is no chance for the blogging in the radiators, etc. Right? So these and all a very advantage one, right? Then the installation is very easy and the cost wise is very cheap. So these are all the advantages of the air cooling system, right? Is it clear? Then for the disadvantages, right? For the disadvantages, right? So every system will have some advantages and some disadvantages also, right? So here the heat transfer rates are less due to the low heat transfer coefficient of the air, right? So uh, if which one is better for a cooling one, right? So whether we have to supply for example, right? For example, if you heat a metal plate, right? If you heat a metal plate and it will be kept into the atmosphere, and the same metal plate will be heated and it will be dipped into the water, right? So which one is having a good cooling one? Anyone answer? So which one is the heat transfer will be good? So whether which is kept in the atmosphere or it will be kept in the water. Anyone answer? Right, water, right? So if you are using the water, right, if you are using the water, so the heat transfer coefficient will be high, right? So while comparing to the first one, right, the metal bed will be heated and it will be kept into the atmospheric air, right? So there the heat transfer coefficient of the air is very very low, right? So the heat transfer also a less one, the heat transfer rate also a less. So therefore, this type of system is only used in a low capacity engine. So where the temperature will be developed is somewhat low, right? So there we can use this type of air cooling system. Then the cooling is not a uniform one, right? So why? Because the atmospheric air, right? So it will be causes some distortions on the cylinders also, right? So it is not a uniform cooling. Then while comparing to the atmosphere, the cylinder wall temperature is high. Right? The cylinder wall temperature is high. If we are using the forced one, that is a fan, right? If we are using the fan used to improve the heat transfer rate means, so we have to spend, right? We have to spend some power to the for the fan running condition, right? So if we are using that forced air cooling system, right? We have used sorry, right? So if you are using the fan, right? So that is called the forced system, right? That is called the forced system. So the fan will be runs, then the extra amount of air will be passing into the system. So the heat transfer rate will be somewhat improves, right? But if you are using the fan, if you are using the external device, right? So it will occupy, right? It will requires, right, some extra power to run the device, right? So the power loss will be there, right? If we are using the forced fan system, right? So there is some power loss, right? There is some power has to utilize, right? So we have to give some power to the fan to run, right? So that one. Then the system will be specific fuel consumption is very high, right? So the specific fuel consumption is high in the air cooling system, and the system will be somewhat noisy, and it will be limits for the compression ratio, right? So most of the petrol engines, right, for the low compression ratio, we can use this type of the air cooling system, but the compression ratio will be high, so the heat developed in the engine is very high. So it is not suitable for the high compression ratio systems. It is not suitable for high compression ratio engines, right? So it will be used, it will be limited for the low speed and the medium speed engines, right? It is limited for the low speed and the medium speed engines, so especially for the scooters and the motorcycles, right? So it will be due to the exposure of the cylinder in the airstream, right? So these are all the disadvantages, these are all the disadvantages of the air cooling system, and these are all the limitations too, right? And it will be limitations too, right? So it is called as the direct cooling system, right? So direct cooling system or the air cooling system, right? So do you have any? So next, for the next class, we can see the second one, that is the indirect cooling system or a water cooling system. In that indirect cooling system, we have the plenty of systems are there, so plenty of methods are there, right? So uh, up to this, right? So if you complete the water cooling system, the entire unit will be gets over, right? So we can see the next week. So every class we can see one by one cooling, right? So for the next class we can see the thermosiphon, and for the next class we can see the forced circulation or a pumped assist thermosiphon, and we have we have to see these five in the next upcoming classes, right? So for this class we have discussed what is the cooling system and what are the types of the cooling system, and we have seen the first type, right? We have seen the first type, that is the direct cooling system or the air cooling system, right? So do you have any doubt in this class, in the system? Do you have any doubt?
No.
No, right? So the unit 3 assignment will be posted. Unit 3 assignment will be posted in your Google Classroom, right? So the due date will be the next Friday, right? The due date will be the next Friday, right? So as soon as you complete the assignment, just you can upload, right? So don't wait until for the next submission date, right? Next due date, right? So then what about today's absentees? I think today the full present is there. Okay, right. So if you have any doubt, means you will stay back. Others can leave the class, right? So meanwhile, I'll send the personal message to some peoples, right? So the Prasanna Venkatesh, Sarveswaran, Prasanna Venkatesh and Sarveswaran stay back, and others you can leave. Others you can leave the class. Then Joel, Jyoti Shankar, you may stay back. Joel, Jyoti Shankar, others you can leave the class.